Welcome AAF kids to Unit 2. Your homework is going to be a handout, and we are going to start linear functions and absolute value functions. Half of this unit is going to be without the calculator and just a real quick review of some Algebra 1 topics, making sure you've got the notation and the forms and the graphing that IB and AP exams need for linear functions and absolute value function, and then we're going to move into a data collection project component of this unit. So there will be both a unit test and a culminating project for this unit. So, if you did notes, there's no warm-up today, but for notes, the formulas for linear equations that you need to know, I'm giving you the worst first. Standard form is not very useful. So, standard form I only use if I'm made to. And usually what I am asked to do is to take an equation in another form and put it into standard form. It is easy to find the intercepts from standard form, and I'll demonstrate that later, but please write that down. If somebody does give me an equation in standard form, you do not want to waste time getting it into slope-intercept form so you can graph. You should graph it right from standard form. So easy to find the intercepts to graph. And again, as I said, sometimes I am required to put the answer in standard form, and I'm not going to give this to you. I will say that IB likes this one better, where everybody is on the same side and you are equal to 0. It is an equation. You have a number in front of x, and the x is first, then the number in front of y, and the y is second, and then the constant that doesn't have any x or y. It is a requirement that the coefficients of x, y, and the constant are all elements of the set of integers. And further, it is a requirement that the coefficient in front of x is a positive integer. Right, so B and C can be negative, but A must be positive, and you have to be in this order. It is A, B, C. Right? X first, y next, then the constant. Point slope form is the best. This is the most useful form of the equation of a line. Please, I need to get you to start letting mx plus b go. It just will get in your way. Point slope form of mx plus b is just a special case of point slope when you happen to have the y-intercept. I don't always have that y-intercept, nor do I need to take the time to find it. This is the easiest way to write equations. And remember, for right now, we just have some integers and maybe some rational numbers to deal with in our equations. But oftentimes, especially in calculus, the things that you're going to be putting in these blanks are nasty. So you don't want to have to distribute and combine, especially when nobody asks you for the y-intercepts. So here, I do need 2 points on the line so that I can find a slope, or I just need 1 point if somebody wants to give me the slope. And remember, slope usually comes with the variable or the notation m, and I want you to think m is for movement. Slope describes movement along a diagonal line. Or, along any line. If it so happens that the point that you are given, one of the points you're given is the y-intercept, well then this form just slopes into y equals mx plus b. So here, these are the two forms. Both of these forms are equally acceptable, and the only difference is here y is by itself, so I can put this into my calculator. So this is y minus one of the y coordinates is equal to the slope that you either have to find or are given minus x minus the x coordinate. So if I have a number here, y minus something or y plus something, I can get y by itself by just moving it to the other side. You do not need to distribute and combine to get this into mx plus b. So here's some examples. So given standard form, I mean, this is minus by, you could think of it as plus by if you want, it's plus a negative b. And this time the constant is on the left side. I'm sorry, the right side. Find the x and y intercepts. And x-intercept is when you want to find the x when y is 0. So go to the equation and plug in 0 for y. So 3x minus 2 times 0 is equal to 6. This goes away, and x is equal to 2. I'm going to plot that point. When x is equal to 2, y was 0. To find the y-intercept, you want to find the y number when x is 0. So go to the equation and put 0 in for x. 3 times x minus 2y is equal to 6. Y is equal to negative 3. When x is 0, y is negative 3. Now this is going to be difficult for me to do here, but the expectation is that you use a straight edge to make a straight line, and please put arrows to indicate you know that this domain and range is infinite. Notice I did not have to get it into y equals mx plus b. Right? 2 points determine a line. I learned that in geometry. Now, over here, point-slope form. Given y equals the slope x minus the x-coordinate plus the y-coordinate, I can see from here that the point that I have is 5, 1. So I will go down here, 1, 2, 3, 4, 5, and 1. Label. And the slope I'm given is negative 2. So I can rise 2 and go left 1, or of course I can go down 2 and right 1, it matters not. And again, I expect you to use a straight edge or just the edge of your calculator or textbook or whatever. You don't have to pull out a ruler. And put arrows on to indicate that you know this goes on forever and ever. So since 2 points determine a line, do please label another point. So if I went up 2, then from 1 I would be at 3, and if I went left 1, then I would be at 4. Remember that the slope is the change in the vertical compared to the change in the horizontal. So, graph and label, check. I identified the point and the slope, I graphed and labeled, and now they want me to transform. This is annoying. So to transform into standard form, I have to know standard form is ax plus by plus c is equal to 0. So here's the equation that I'm working with. First thing I notice is I do need to get rid of the parentheses, so I'm going to say y is equal to negative 2x plus 10 plus 1, which is plus 11. I'm going to move the x's over here, so 2x plus y is equal to 11. You could just leave it like that, or you could move over 2x plus y minus 11 is equal to 0. I would take, since they didn't say which particular standard form they wanted, you could give me either one of those and it would be full credit. Sometimes IB will say transform into standard form, and then they will give you the form, which is nice that they give you the form, but you best match it if they give it to you. So notice I am now in the form where A is 2, B is 1, and C is either 11 in this form or the opposite of 11 in this form. Don't transform into standard form unless somebody makes you. So I've demonstrated that if somebody gives me standard form, I can graph it. I don't have to waste time putting it in slope y-intercept form. If somebody gives me point slope form, I can go right to graphing. I will not transform unless somebody makes me. So this is the formal definition of a linear function. So make sure that you write this down in your notes. A linear, notice root word line, function. So we already know that we have to linear function. This isn't a definition of a line. It's a definition of a linear function. A linear function is a function whose equation can be, not must, can be written as y equals a coefficient in front of x plus the y coordinate. And notice this, where the slope and the y-intercept are real numbers and your slope is not allowed to be 0. Neither is your slope allowed to be, and it is kind of just understood that this also means, of course, since your slope is a real number, you cannot have an undefined slope. Notice that in y equals mx plus b, the coefficient on y is 1 and the coefficient on x is 1. If I see both an x and a y with a power of 1, I definitely have a diagonal line. Either a decreasing diagonal line or an increasing diagonal line, but I do not have a flat horizontal or vertical line. Neither one of those are linear functions by this definition. Please make sure in your notes that you write gradient next to slope. IB loves, loves, loves to talk about the gradient. So on an assessment, a question might say, what is the gradient of the line passing through these points? You cannot say, what is a gradient? I just told you. Gradient means slope. So you have certainly, I hope, have seen the slope formula before, but you need to start getting used to thinking of it as delta. This is the Greek letter delta, means change. Change in the vertical compared to the change in the horizontal. It is a rate of change. Rate. Right? Rate of change, think fraction, think comparison. And somebody before you and I were born decided it was going to be vertical compared to horizontal. So there is a picture of an increasing line. Here, this represents the change in the horizontal, and here represents the change in the vertical. Let's pretend this is 3 and this is 2. This slope of this line would then be less than 1. Right? You ran farther than you rose. But this line, if I gave the same thing, this delta x is still 3, this delta y, is 2, but notice I don't get all the way up to my line. I have to extend this. So this delta y is not 2, let's pretend it's 4. Therefore the slope of this line is greater than 1, and notice the relationship. Slope less than 1, less steep, greater than 1, more steep. This is a change in x in the left direction, so we call that negative. So let's pretend this is negative 3. And this change in y is in the up direction, so we call that positive. Let's say it's also 3. So the slope of this diagonal line is negative 1. Here is a constant function. This is not a linear function by definition, even though plenty of us call them lines. Notice that the change in x is 3, but the change in y there is no vertical change. So the change in y is 0, which means the slope of this line is 0 over 3. And if my numerator is 0, my slope must be 0. If my slope is 0, I have a constant function, not a linear one. Notice that vertical lines do have slopes, right? This is a change in y. Let's pretend it's 3. It's just that the change in x is 0 because there is no horizontal change. So the slope is 3 over 0, and since we put delta x on the bottom, this is numerically undefined. But the movement still exists, right? Go up and down, and don't go right and left any. So I have lots of kids that'll tell me, oh, a vertical line doesn't exist. A vertical line exists. It's right there. It has an equation. X equals a constant. Its slope is numerically undefined. So this linear function does not have an x to the first and y to the first. It only has a y. It is not a linear function. This is a constant function. This has an x to the first. It is certainly not a linear function. As a matter of fact, it isn't even a function. If you have an equation with y to the first and x to the first, then you have a diagonal line. Either increasing or decreasing over the domain. A constant function is flat, no vertical movement. A vertical line is straight up and down, and it is not a function at all. Interesting. There's y equals 3. Here's x equals -2. Guess where those two meet? If y is always 3, and here x is always -2, where are they going to meet? Yay! Alright, here's some practice. I have a sheet with these problems, and I have some graph paper for you. And I want you to work on the paper and the graph paper, but I also want you to go to Goformative and use this class code if you don't already have it stored. Go to Goformative and enter your answers into the Goformative so that I can check your responses, and I'll have them put them up on the board. So if you click on this link, it should take you to the Goformative site. And click on the linear practice. And of course, these are my answers, but I want to see if you can get your answers, the correct answers. Alright, I will see you later.